going to get started. So as you can see, the title is The Fun Task of Securing Your Kubernetes Software Supply Chain. I must say, I'm very grateful that you actually came through for this one because I thought most people would assume that there's no world in which these three concepts can coexist: Kubernetes, security, and fun. And if we're honest, well, firstly, are there any security officers in here? Just want to be careful and just figure out who not to offend. Oh, perfect, we're in a safe space. Right, so security is usually that topic that puts people to sleep or reminds them of those back-to-back arduous meetings where you're like, I can't wait to get out of here. Right, and in the Kubernetes space, it's very complex and it's vast. And because of Kubernetes' popularity, it usually gets neglected. So believe it or not, even though security is usually not fun, I'm actually excited to give this talk because I do think it's really important and there are going to be some golden nuggets in here. And there are few people in here, so if I catch you sleeping, I will find a way to get you up, all right? So stick around for the show. So just for starters, my name is Lukonde Mwila, or you can call me Luke, and I'm a Principal Technical Evangelist at SUSE. If you have no idea what a Principal Technical Evangelist is, not to worry. I felt the exact same way before I took on the role, and I think a lot of us who fulfill this role are still trying to figure it out. Just a few other titles. I'm also an AWS Hero and a HashiCorp Ambassador. And before I was in this current position, I have had work experience in application development, both web and mobile, business systems and SaaS products. And then I transitioned into the consulting space, specifically the financial services sector, where I focused on cloud solution architecture and implementation and DevOps workflows. Right, so I've got a couple of things lined up for us today. And if you take a look at this agenda, you'll notice that it doesn't necessarily scream software supply chain. And that's on purpose. I think one of the problems with security in the Kubernetes space is there's a very narrow-minded conception around it. And this is to the detriment of people and teams and companies that are running Kubernetes in production. They drastically undermine the many other issues that they should be considering in the Kubernetes space. So what I'll be trying to do is to come from an angle where I paint the big picture so that even when you're thinking about your software supply chain, it'll be in the context of this big picture. The software supply chain is just a small piece in the puzzle. Just out of curiosity, who here is running Kubernetes in production? Okay, great. So I'm not sure if you've come across other people and asked them, hey, how are you carrying out security in your Kubernetes space? Usually, with the conversations I've had with people, their response is, well, we are scanning our container images in the pipeline. I'm like, great, that's important, and we'll touch on that. What else are you doing? We're scanning. We're really, really scanning those container images for any dependency vulnerabilities. And then when they end up in the cluster, we've got secure workloads. That's a problem. And that's because of that same perception of just narrowing things down to one particular aspect. So I want to be focusing on the big picture in this session as well, because I think there'll be a lot of value that you can get out of it. Great. So for starters, we are going to talk about the fun topic of Kubernetes' popularity. Now, I noticed there were a couple of hands that went up when I asked who here is running Kubernetes in production, so I'd assume that there's some Kubernetes love in here. And I saw someone nodding, which is great. And if you've had conversations, is anyone here an application developer? Okay, we've got a couple of application developers. So in my conversations with application developers, they do not like Kubernetes. And that's me putting it lightly. It's usually the operator game. It's for operators and DevOps and SREs. Keep it out of my space. But it's somewhat unavoidable at this particular point, because if you've been paying attention to what's happening in the cloud-native space, have a look at the most recent CNCF survey. This was one of the first things that they shared. They pointed out that Kubernetes has gone mainstream, not just Kubernetes, but containers as well. And this is a great thing. It's really exciting. I love the problems that containers and Kubernetes actually solve. However, the problem with popularity when it comes to the tech space is sometimes it rides so far ahead that there's a lot of neglect on actually focusing on problem definitions. And this is one of the things that has resulted when it comes to the security space. So as you'll notice over there, I've pointed out that widespread adoption of tech doesn't necessarily equal widespread adoption of best practices. There are situations in some organizations where they hear that their competitor is running Kubernetes. And they're like, oh, okay, so you know what we need to do? You're going to run Kubernetes, whether you like it or not. And I've actually been in a space like that. I've worked in a team where we were using a different container orchestration platform, and it was going relatively well. We had our first release, and it was a POC to a select number of users. And then next thing, it's like, all right, we have a review, of course, of how things went, and then it was good. And then the powers that be decided, now you're going to shift everything to Kubernetes. All right, so that's just an example of that. And then you're given a strict deadline, and it makes it difficult to implement best practices. So these are just examples that result in the neglect of security. So if you were to secure a building, let's take the example of a building. You would go through different measures to keep whatever particular object that you're trying to keep safe, right? And there are usually two things that inform the security measures that you're going to put in place. The first one is how valuable is the thing that you're trying to protect. Now, in this context, it'd be your containerized workloads. You definitely want to keep them safe and secure. The other thing that's going to inform that is a good understanding of the attack vectors. There are different forms of securing a building. You could have a wall fence, you could have dogs on the premises, you could have armed response and laser beams, et cetera, et cetera. And you could do all of those fancy things, which are important, but if you put the cart before the horse and go there, and yet you actually never did a study or analysis on the weak points, well, if there are others who actually know about the weak points, they could just exploit you there, even though your whole front perimeter is covered, but you forgot about the back. So it's very important to start off with understanding what are the attack vectors. And if you recall, what I said at the start is I want to take a different angle when it comes to securing your software supply chain. The popular approach is to focus on scanning images in your CI/CD pipeline. That's just a small piece in the puzzle. But are there things that you can be made aware of for securing the cluster as a whole that can actually all be shifted left? And there are. But it all starts with understanding what are the attack vectors and how do we secure our cluster. And then you'll be in a better position to understand the things that can actually be shifted left. Cool. So this diagram just depicts a Kubernetes cluster. On the left-hand side, you've got a node that represents the control plane, and on the right-hand side, your right that is, you have a node for the worker plane. And so for those of you that aren't very familiar with how Kubernetes works, the control plane is essentially the brains behind the operation. All the super important components live inside of the control plane. That's not to say that the worker plane isn't important. The worker plane is essentially your workhorse. That's where your workloads are run. And you'll notice that there are a lot of different arrows over here. And all of this is just to give you a picture of the different points that can be exploited when it comes to your Kubernetes cluster. This goes a lot beyond just your supply chain. And we'll get to that, which is going to be mostly about the workloads. But let's take a top-down approach over here. We'll start with the underlying infrastructure, your nodes, for example, right? Whether you're running VMs or if you've got an on-prem approach, those of you that have spun up Kubernetes clusters or invested the time in understanding its architecture, you'll know that your nodes only need to expose specific ports in order for Kubernetes to work, because there's a lot of network communication taking place in your Kubernetes cluster. And so there are only specific node ports that need to be open. So you need to protect all the others by having the right firewall rules in place. But if you don't do that, that's an attack vector that can be exploited. If we go a step up beyond just the infrastructure layer, let's talk more about Kubernetes itself. And we're going to focus on the control plane. And I'll start off with one of the three main components in the control plane. We've got the API server, we've got the scheduler, and our controller manager. Kubernetes is an API-centric platform. That means every kind of CRUD operation that is going to be run on Kubernetes is going to go through the API server. And by CRUD, create, read, update, delete. Whether those requests originate from inside of the cluster or outside of the cluster, everything goes through the API server. It's like your gatekeeper. And that is probably already giving some of you an idea of, oh, okay, then that's pretty important, and we need to secure that. Now, there are different models that exist when it comes to exposing the API server. It's very popular for people to use hosted clusters, for example, GKE, AKS, or EKS, and you can have different network modes for your API server endpoints. You can have a public endpoint or a private endpoint, or both. And now, as long as you understand what the API server is responsible for, then even that starts to inform how you go about securing it. You don't want to just jump in and say, well, we need it to be public because we want our operators across the globe to be able to hit that endpoint. Well, do you understand the implications of making it public? And obviously, if you're going to go private, which is a highly recommended approach, just understand that you know the roots of doing that. But that's another attack vector over there. And then, just within the control plane as well, these different components are continuously communicating with the API server because, as I said, it's API-centric. All requests go through it. And then we've got our data store. Most popular implementation of this will be with etcd, right? But you can also use lightweight versions. For example, is anyone here working with K3s, or have you ever worked with K3s? Okay, we got one person there. Great. So K3s is basically gives you a small footprint or a lightweight form of Kubernetes. So it downsizes a lot of things. You can run your Kubernetes cluster on a Raspberry Pi using K3s. And so the data store is almost like the keys to the kingdom. All of your cluster configuration is stored there. So bear in mind, though, that the data is not encrypted at rest by default. And so if you're going to jump into Kubernetes and say, well, I think everything is already secure, that's a big misconception. It doesn't get championed enough that Kubernetes by default is insecure. And that's a very important component that you need to be aware about. Okay, so also, if you're going with a highly available model, and in a highly available model, it simply means you have multiple nodes because you don't want to have a single point of failure, and that's a very good approach both for your control plane and the data plane. The data plane, this is where your data store exists. You're just going to have multiple instances. However, because of the continuous traffic, you want to make sure that you actually secure that as well. Now, if we move over to the worker plane side of things, and the node on your right and my far left, there is the kubelet. And the kubelet is our agent that communicates with the control plane. It's also communicating with the different container registries in order to pull the relevant container images so that it can spin up the pods on the worker nodes. But it has an API. So you also need to be aware of what the vulnerabilities are with that particular component and how you can secure this. A big thing when it comes to securing the network traffic is certificates. Certificates. Huge help across the board to make sure that you have TLS and that all of the network traffic is encrypted. Then we get to the workload level, and this is something that is probably the easiest to shift left. So your containers and making sure that you're actually aware of the dangers that exist with the different dependencies for your particular applications. Those are some of the things that you should be aware of. Now, I'm not going to spend too much time here on this diagram, but I thought it would still be useful to paint a picture of the things that would help you when it comes to securing this plane. Some of you might have been very aware of these different attack vectors. Maybe you're actually just solely responsible for the Kubernetes security in the particular one the cluster that you're administering, or the multiple clusters you're administering. But this is meant to just give you an idea of how you can secure the different aspects of your Kubernetes cluster. And please keep in mind what I mentioned before. Big picture will help inform even how you do your software supply chain. So you'll notice over here we've got those 4 arrows that are coming out of what is representing our cluster. We've got hosts, cluster components, auth-n and auth-z, which is authentication and authorization. And then over here we've got workloads. And around those, I've just demonstrated, or rather pointed out a couple of examples of how you can secure these different aspects of your cluster. So for starters, your hosts, as I mentioned already with the node ports, make sure you have the right firewall rules in place. Don't leave the unnecessary node ports exposed. And I'll talk a little bit more about node ports later. Then there's also the operating system. This is the boring stuff, let's be honest. And that usually results in people neglecting it, but it can have serious implications. Do you have a system in place to actually carry out continuous upgrades for the particular operating systems that are running on your hosts? Because that's an important thing, especially for security patches. And for those operating systems, do they actually support networking tools that allow Kubernetes to make use of new security features and to also have monitoring in place? And then we consider the cluster components. The cluster components encapsulates the different ones that I spoke about from the control plane and the worker plane as well. And a big one here, as you can see over there, make use of PKI certificates for TLS authentication. Secure the data in transit. This is a big, big win. Kubernetes is a network-centric system, so pay close attention to that aspect. And then there's auth-N and auth-Z, right? Authentication and authorization. And this is something that we apply in other systems as well. It's not exclusive to Kubernetes, but have a system in place to be able to identify or make it clear who is allowed to do what in the cluster, both with users as well as the pods that are going to be running on your cluster. And as for authorization, find the right kind of model as well for the access control and the permissions. And then workloads. With workloads, network policies are super important. And I'll elaborate on these further a little bit later, as well as policy enforcement and how you can carry that out. So I think understanding the attack vectors and the different forms of solving those attack vectors will help you, not just for the cluster itself. This is more of, so there's runtime, and then there's also the software supply chain. But start to think around how they can complement each other, and it all starts with the big picture. And I thought it would be useful as well. Some of you here might be wondering, okay, so I'm actually going to be spinning up a cluster soon, or maybe you've already got a cluster spun up, and you're thinking around, how do I know that I've got, because there's a lot, right? There are a lot of things that you need to consider. And is there some checklist out there that can help me to basically check whether my current implementation of my Kubernetes cluster meets certain standards? And the CIS have come up with a particular benchmark. So the Center for Internet Security. You don't need to go and start doing your homework and spend the next 2 years trying to figure out all the different ways of doing this and coming up with your own standard. The hard work has been done. And so you can make use of QBench, which is a tool that you can download and actually run it against your nodes, both the control plane and the worker plane nodes, and basically run assessment tests to check if it meets the certain standards that have been set by CIS. And you'll notice there in the bottom right corner, yes, that is your bottom right, perfect. In the bottom right corner, there's another tool over there that I've put, NewVector. So NewVector is actually a tool by SUSE, and it's an open source platform. So we recently acquired NewVector, and they actually carry out full end-to-end cloud-native security. So this is not just supply chain, but also runtime as well, and it's very comprehensive and gives you a deep level for your cloud-native security. So it's a great thing to be able to actually run the scans and figure out where you fall short in terms of your particular cluster, the areas that you need to beef up, so to say. But the next step is actually solving those problems. And so a tool like NewVector can be a huge help in actually figuring out those pain points. Cool. Now let's talk about shifting security left. And these are becoming buzzwords, right? Also because of DevSecOps. And DevSecOps is rising in popularity, which is a good thing. We need security to become more popular, right? But I find that the concept of shifting security left is still falling into that ditch of a very narrow approach. Speak to people and ask them, hey, how are you shifting security left? We're scanning images in the pipeline. Well, what else are you doing? What if you thought about it as a culture? What if it was a culture that was informed, again, based on the attack vectors and the different solutions for those attack vectors, and then you have this culture around how you can solve those different problems and try to catch them early on as possible. For those of you that are totally new to the concept of shifting security left, it's basically the idea of trying to catch things early on as possible. If you think back to the example or analogy that I gave about securing a building because there's something very valuable in that building, it's the same concept as, you wouldn't leave all the doors open and have no security and wait till some kind of perpetrator gets right to the object and just have the laser beams right around that object. You try and catch the threat as early as possible. So that's the same idea, but we need to start broadening our thinking around this concept of shifting security left. And so you'll notice in this slide, I put a picture of a person who's looking confused, or at least I hope he looks confused. And this is meant to just portray that same thing. I think there is confusion around this. And this is the beauty of the tech space. I think sometimes we forget that we can also shape these paradigms ourselves. Sometimes we are too busy caught up in waiting for someone else to set a trend or a best practice when you don't realize that you can actually inform that as well. And this is open source technology. You are a contributor to this ecosystem. And I think the idea of shifting security left should be prioritized as a culture and not just the concept of scan images in the pipeline. Now, again, I'm not trying to bash the concept of scanning images in the pipeline, and we're going to touch on that, right? And so that's why I've actually put out some tools over here to help you with that. Some of you might be using Aqua or Sneak, which are particularly helpful for these processes, and I've put NuVector there as well because, as I mentioned, it gives you that end-to-end security, so you can also use NuVector for scanning your container images. But now I want to show you an example of treating shifting security left as a culture. So, what if we looked beyond the CI/CD pipeline? What would come before that? It would be the developer workflow, right? And depending on the culture of your company or your team, the level of competency or proficiency around Kubernetes will vary when it comes to developers. And I think that, again, this is my personal opinion, I think developers should be given a lot more room to focus on building out requirements, right? They're given certain specs for a particular application, and a majority of their time should be devoted to building out that particular application. And the cloud-native space recognizes this. That's why there are tools that are coming out a whole lot right now, trying to simplify the process of developing and deploying cloud-native applications. We're trying to help out developers to focus on their core responsibilities because a lot of these things shouldn't be under their purview to begin with. And so that still introduces some challenges. So I want to give an example of one tool. For example, Scaffold. Has anyone here heard of Scaffold or used Scaffold at all? Okay, one person. Cool. Scaffold's great. Okay, 2 people. Scaffold's great. Check it out. Scaffold essentially allows you to streamline the process of building and shipping your cloud-native applications, not just to downstream clusters or remote clusters rather, but even local clusters that you may be running on your laptop. It's super helpful. And it automates the entire process. And it's meant to complement developers who are in the paradigm of the inner developer work loop, the process of building, testing, coding, debugging, etc. So that they can focus on that, and Scaffold will essentially generate all the Kubernetes resources on their behalf. And in addition to that, it will also deploy the generated Kubernetes resources to the local cluster. And that way, you have a developer who can make use of a tool like Rancher Desktop on their local machine and just focus on deving and leave the other stuff for the DevOps and SRE and sysadmin people. But some of you might have picked up on this. Let's say tools like Scaffold continue to increase in popularity, and that's a good thing. Or if you're not making use of that tool and you're kind of trying to get your developers to learn Kubernetes a whole lot more, the reality is there will be some neglect because Kubernetes can get deep. So how do you protect your Kubernetes resources in a situation where a developer isn't really proficient with Kubernetes resources? So Scaffold sounds great, right? It automatically generates those manifest files for you. Developers don't need to know what a pod manifest file looks like. They don't need to know what a deployment manifest file looks like. It gets generated for them, and then they're happy with what the application looks like as they've developed it, and next they're about to commit that code to the Git repository. That's risky. That is risky. So how do you put a protective measure in place for that? So again, this is the developer workflow. You'll notice there's a tool over there that says Detree. This is where policy enforcement comes in. And policy enforcement is essentially the process of making sure that any Kubernetes resources, whether you're using Helm charts or customized templates or raw manifest files, they meet a certain criteria that you have set. Examples: containers should not be running with a root user. Now, some developers might not be informed about that, or maybe they know about it, but they're too consumed in debugging an issue, and then when they're done with debugging that issue, they're exhausted, and they're just like, whatever, I'm committing this, and bam, right? So policy enforcement will allow you to prevent something like that happening. And I just used the example of running containers as a root user. There are other things that you can you can enforce as well from a performance perspective, making sure that you never have a deployment that gets committed unless it has at least 3 replicas defined. And then there are other things as well. I said that I'd speak a bit about node ports as well. Node port services, I find, are usually really good, especially when people are doing local development. That's not to say there's no place for them in a prod situation. However, just be aware of the risk that that poses. The more node port services you have in a cluster, the more physical ports you are opening up on your infrastructure. That's a security risk as well. So that's why it's so good to emphasize certain things like make use of an ingress, because an ingress is going to enforce just having, or rather, allows you to just have a single external load balancer. Traffic goes through that single external load balancer. You have routing rules in place for your ingress, and then it will proxy traffic to the different upstream servers, which are your services in the Kubernetes context. And you can have all these services that are just cluster IP services, and so they're restricted to network within the cluster. Those are things that you can actually enforce in your developer workflow. And so now, developer is there, he's happy, application is working as expected, he tries committing some code, and you can use the tree for Git hooks, and it essentially prevents that from happening because, hey, this doesn't meet the criteria that's been set, the security criteria that's been set by the team. And so you get to shift your security even sooner to the developer workflow process. So that was just an example of how you can go beyond the existing norms that are more prevalent, but you start thinking about shifting security left as a culture. Now we're going to talk just a little bit about container image scanning. And like I said, I'm not going to spend too much time here because this is the no-brainer that a lot of people are carrying out. And so you'll notice in this particular diagram, this is an example with NuVector. But for those of you that are totally new to the concept of container image scanning, this is really, really important. Your container images consist of several different layers. And in today's world, where we do want to make use of dependencies and packages, so we're not reinventing the wheel, you want to make use of so many different, you're going to be sourcing so many different software packages, but you're not in control of what's inside of those software packages. So you need to make sure that you have the relevant scans in place to check for any vulnerabilities. And a part of this process will be to essentially set a particular threshold based on certain severity levels, and then if a certain severity level gets hit, then you fail your build. So this is a really, really important step. So I'm not surprised that it is the most popular concept when it comes to shifting security left. I'm just big on the concept of it's not the only thing to do. For those of you that are interested in trying out NuVector, and if you're working with Circle CI, because I know Circle CI is a really popular tool as well. We do have an orb that you can make use of, and there's a really cool and simple example that you can find online on how to make use of that and integrate it into your pipeline. So if you're totally new to NuVector, go check that out and try and build it out in a POC. Cool, so now I'm going to talk a little bit about network policies and authorization. And this is me just taking some of the examples from things that are in the big picture. So if you think back, and I spoke about how to secure your workload, network policies feature in there. And then I also spoke about how one of the solutions for access to the cluster and what gets carried out in the cluster was authorization. So I'm taking two of the aspects there that have a high impact on your runtime, and I'll show you how you can shift that left as well. But I don't want to assume that everyone is familiar with network policies and how they work. So network security policies are basically Kubernetes objects that allow you to enforce the ingress and egress traffic for the pods that are running inside of your clusters. Now, to make use of network security policies, you do need to deploy a network CNI plugin that will support them, like Calico or Weave or Cilium. So just make sure to actually have that in place. But this is a really, really important concept. And it's a popular model when it comes to multi-tenancy. So multi-tenancy is usually when you're going to have either a number of independent workloads, what could even just be two, very independent workloads, or you have multiple teams that will be accessing the same application on a particular cluster as well. So how do you control having, let's say, different testers, sysadmins, developers, and they're all engaging with the Kubernetes cluster? But now at a network traffic level, you can actually control and basically scope things to a level of namespace, or only pods with this particular label can actually be able to communicate, and you can do that both for source and destination. This is a super important concept. And then there's authorization. And there are different ways of carrying out authorization. Over here, I've just specified role-based access control. Again, I think this is one of those that, because it's such a popular approach, people kind of forget that there are other ways of carrying out authorization as well. There's also ABAC, which is attribute-based access control. So if you want a very dynamic approach for business rules and how you carry out your access control, you can use ABAC. There's also webhook authorizers, and there's also node authorizers as well, where you want to be able to control, I believe it's the kubelets behavior with carrying out certain actions. Now, the reason I'm putting this here as well is because in a number of instances, at least in my engagements, people just use the default service account for their pods. And I can see someone nodding as well. And so they're nodding quite emphatically because that usually happens. And that is a problem. So remember, Kubernetes is API-centric. You have to control what the different entities or objects are allowed to do in the cluster. And role-based access control can help you to enforce that. So you can implement RBAC using different Kubernetes resources. You've got a role, you've got role bindings, and you've got cluster roles and cluster role bindings. So the role is where you would define your different permissions and the APIs in Kubernetes that are actually allowed to be hit, and the particular actions that can be carried out on those different APIs. Now, a role binding is what you would essentially use to attach that to either users or to particular pods. Now, in the case of pods, this is where service accounts come in. Make sure you're creating a specific service account, and that service account gets attached to a particular role. So this is very important for the runtime level. So the next thing might be, okay, Luke, so how exactly does that fit in with shifting things left? And I've actually already given you the answer. Policy enforcement. Policy enforcement. Policy enforcement is something that you can do, remember, as far back as the developer workflow. So way back when the developers were building out a particular feature or refactoring something or debugging, at that point, if they were in the process of creating a new service account, but they didn't necessarily know the details of creating a role or a role binding, etc., you could essentially enforce that in as early a step as that. But in addition to that, you can also bring that to the CI/CD pipeline. And some of you might be thinking, well, why would you do it twice? There's an important concept when it comes to security, and I'm sure some of you have heard of this, defense in depth. You're putting as many layers as possible to protect yourself. So, like I said, I just used the concept of network policies and auth-z as examples to show you things that impact the runtime in a huge way, but you can still bring them forward. And I'm just going to talk briefly about admission control and policy enforcement because I've already been touching on them. And so not only in your developer workflow process, but also in your CI/CD pipeline, you can make use of both. You can make use of a tool like NuVector to help ensure and run those checks. So let's say your container image passes the relevant scans. It meets all of the criteria. Well, don't be too quick to carry on with the deployment. The next thing is to make sure what's going on in those containers. And what's going on with those particular resources that you're about to deploy, those raw manifests or those Helm charts? Is there a service account? Is it the default service account? Because if so, fail the build. Are containers running as root? If so, fail the build. So not just in the developer workflow process as well, but also in the CI/CD pipeline. Because remember, the developer workflow process is local to someone's machine. So as much as you might be using a tool like the tree, which has a centralized hub where the criteria has been set, the developer can still get rid of those Git hooks, especially when he's trying to accelerate his development. And that's something that's pretty hard for you to control. You can call him and yell at him all you want, him or her, and then just, boop, okay, where was I? So have it running in the CI/CD pipeline as well, and that helps enforce this same principle. Cool. And now I'm going to talk about managing secrets. Secrets, secrets, secrets. This is an interesting one. And when I chat with people about how they're making use of secrets in production context as well, I get some pretty interesting responses. In fact, the last person that I spoke to about this shared with me that, so what we were doing is our secrets, we're just using base64 encoding for encryption. Base64 encoding for encryption. And that's it. That's a problem. And it is a little bit funny when you know how risky that is, because base64 encoding is not encryption. It is very simple to get the original values by running a simple command, right? But this kind of goes back to what I started with. When there's so much popularity and adoption around a tool that it usually results in the neglect of some of the best practices. That's how these things trickle down. It's not that these people who end up doing this are just like, it's cool, whatever. No, it's a lack of information because of various factors. Now, the reason I'm mentioning secrets over here is because you're going to be storing your Kubernetes resources in a repository, right? You're going to be storing them in some kind of Git repository. If you're storing them somewhere else, we can chat about that afterwards. I'd be keen to know and to hear more about that. But because of the nature of secrets, especially for people who are uninformed about how to actually secure their secrets, they're not going to be committing them to a repo because they know, hey, this is just base64 encoding. So what is the next step when people are in that situation? And I've been in a team that was doing this. We can't store our secrets in a Git repo, so we will create them manually every time. And we're going to do that for the different environments as well. And someone just gave me a very weird stare. Hey, it was tough times, bro. Okay? So cool. So I've already spoken about how they are insecure. It's just base64 encoding. A quick fix over here, because they are not encrypted at rest in your etcd data store, you can enable that. I don't know why it's not enabled by default, but that is a very quick fix. But let's go beyond that, because we're trying to automate things, right? We want to have everything stored in our Git repository so we can version our infrastructure. But we've had the challenge with secrets because of the whole base64 encoding. And some people might be thinking, but what if it's a private repository? That's secure, right? Well, not necessarily. What if the wrong people get their hands on that? Even if you're in the same organization, some of this information shouldn't be visible to everyone. And there are a couple of tools out there that you can use. So Sealed Secrets is one of them. The two others are Mozilla SOPs, S-O-P-S. That's the same Mozilla that gave us Firefox. And there's also Helm Secrets. So Helm Secrets uses Mozilla SOPs in the background. So Sealed Secrets allow you to essentially have one-way encryption of your secrets. So to take some of you back to your computer science days, when you were falling asleep in that class, that cryptography class, you would essentially have a system of generating a key pair, a public key and a private key. One of them is used for encryption, the other is used for decryption. So with Sealed Secrets, there are two main components. You've got KubeSeal, which is a CLI tool that will interact with, or rather use, the public key certificate to encrypt your secret, and that will generate what is known as a sealed secret. Once you've got that sealed secret, you can post it on Twitter, and you're fine. I'm not saying do that. But essentially, you are okay. And then you've got the Sealed Secrets controller. The Sealed Secrets controller is running inside of your Kubernetes cluster. So that's actually what generates this key pair. So it has the private key, and when you submit a sealed secret to your Kubernetes cluster, the Sealed Secrets controller will be able to decrypt that with the private key and expose it as a normal secret. So this diagram is just to help give you an idea of how this actually works. So as I mentioned, you've got your controller, generates the private key, generates the public key. The public key is something that you can download and use with KubeSeal in order to encrypt and produce a sealed secret. And then that sealed secret can now go in your Git repository, and you don't have to manually or ad hoc run commands to create your secrets manually. And if you're following a GitOps model, this allows you to also automate that process as well. Shameless plug. I'll be doing a GitOps talk later, so Please show up for that. Cool. Now, I understand that in enterprise contexts, things can start to get a little bit restrictive. There's a lot of red tape as well, especially in the security space. You might be in a situation where there's a policy across the board that you have to use some kind of secrets manager. So like HashiCorp Vault or AWS Secrets Manager or IBM or Google, etc. So some companies are like that, where you have to use a centralized approach to that. So all of the secrets are stored in there. And then that begs the question, okay, so how do we get those secrets into our Kubernetes cluster? And so there's a tool, External Secrets Operator, and you can make use of the External Secrets Operator to essentially securely fetch your secrets from a centralized management system and expose them as secrets inside of your Kubernetes cluster. And so there are a couple of different components, but the ones I'm going to focus on are the secret store and the external secret store. So the secret store is a namespace resource that determines how your external secret resource is going to fetch the relevant secret values. And then the external secret is where you would specify the actual values that you want to get from that secret in your centralized management system. And I know that's a whole lot of secret in there. So this will paint the picture a little bit better. And there's something that I want you to pay attention to. So let's see if my pointy is working. There we go. All right. So there's the secret store, and there's our external secret. So secret store takes care of how our secrets in AWS Secrets Manager are fetched. So we want to fetch first and second. And then the external secret component is where we would actually specify the secret values that we want to get. So this deals with the how, and this deals with the what. But you'll notice there's a secret over there. And this secret is what is actually going to define the credentials, whether it's HashiCorp Vault or Google or IBM, etc. And someone's laughing because I think he got it. This is where you would specify the credentials that the secret store is actually going to use in order to fetch those values. We're back to problem number one. How do we secure that particular secret? And so this is why I think it's really complementary to make use of an encryption tool, whether it's sealed secrets, Mozilla SOPs, etc., because then you can use sealed secrets for that particular resource and have all three of these in your Git repository and reduce the particular risk. And like I said, once those values have been fetched, it'll expose it like a normal secret, which can then be accessed by your pods, either mounting them as volumes or environment variables. Cool. So I hope that was helpful. Took a bit of a risk here with my cultural approach to shifting security left, but it's something that I'm definitely trying to advocate for because, like I said, Kubernetes security space is massive, and I think there are a lot of misconceptions around it, and so we have to start thinking more broadly about it, and so I hope this helped paint that particular picture. Cool, so I'm not sure if there are any questions. Actually, Eckhart, do you know how much time I still got? I'm out of town? I'm out of time. Okay, perfect, cool. Sorry about that, I think I went over, but I certainly hope that was valuable. If any one of you want to chat with me, we can definitely do so. Thanks for coming through.